Welcome back. In this tutorial, we're going to learn some of the most important Docker best practices used in real DevOps and cloud-native environments. We'll explore how to build optimized Docker images, improve security, reduce image size, manage environment variables correctly, and create more production-ready containers. Let's get started. Let's start with an example of a poorly optimized Docker file. This approach works, but it creates larger images, unnecessary layers, slower builds, and less efficient containers. Using large base images and unnecessary layers increases image size and slows down the Docker build process. Also, copying the entire application before installing dependencies prevents Docker layer caching from working efficiently. First, let's build the poorly optimized image. Notice that Docker needs to install node.js and npm manually on top of Ubuntu, which increases build complexity and image size. Here we can inspect the final image size. Because we are using Ubuntu as the base image and installing everything manually, the image becomes much larger than necessary. Here we encountered another common Docker issue during the build process. The image build failed while executing npm install inside the container. This is another reason why manually installing node.s on top of Ubuntu is usually not the best Docker approach. Now let's improve the Docker file using a smaller node Alpine image and a more optimized Docker build workflow. Instead of using Ubuntu as the base image, we changed the from instruction to use the official node Alpine image. This approach is much smaller, faster, and more optimized for Node.js applications. Next, we added the workdir instruction. Workdir defines the default working directory inside the container where the application files and commands will be executed. We also removed the manual run commands used to install node.js and npm. Because the official node image already includes everything required to run Node.js applications, the Docker file becomes much cleaner and simpler. After that, we copy only the package.json file first. This is a very common Docker optimization because it improves Docker layer caching and avoids reinstalling dependencies every time the application source code changes. After improving the Docker file, let's build the image again. This time, Docker fails because the package.json file does not exist yet inside the project directory. To keep the example simple, I already prepared a basic package.json file for the application. Once we add the file to the project, Docker will be able to continue the build process correctly. Here we can clearly compare the Docker image sizes. Most of the previous application images are larger than 1 GB because they were built using heavier base images and less optimized Docker configurations. But the optimized application image is significantly smaller because we use the lightweight node Alpine image and a cleaner Docker build workflow. Smaller Docker images are faster to build, faster to deploy, and more efficient for production environments. Another important Docker best practice is using a dockerignore file. This prevents unnecessary files such as node modules, Git metadata, and environment files from being copied into the Docker image. For example, in the previous debugging project, we configured the PostgreSQL password directly inside the application code using the value secret. Even though this works for learning purposes, hard-coding credentials directly inside the source code is not considered a good practice for real production environments. A much better approach is creating a separate .env file to store sensitive environment variables such as database passwords and API credentials. Inside the .env file, we can define variables like db_password and then access them directly from the application code using process.env. Earlier, we also added the .env file to the dockerignore configuration. This prevents sensitive files from being copied into Docker images or accidentally uploaded to repositories. Using environment variables and excluding sensitive files is considered one of the most important best practices in modern software development and DevOps environments. Another very important Docker best practice is keeping the Docker environment clean. Over time, Docker accumulates unused containers, images, cache layers, and networks that consume disk space unnecessarily. To clean unused Docker resources, we can use the Docker system prune command. Here, Docker is showing all the unused resources that will be removed from the system. This includes stopped containers, unused Docker networks, dangling images, and old build cache layers. After the cleanup process, Docker reclaimed more than 1 gigabyte of disk space. Keeping the Docker environment clean is very important in real development and DevOps environments because old containers and cache layers can consume a large amount of storage over time. After the cleanup process, we can inspect the Docker environment again using Docker PS and Docker PS-A. Notice that only the active containers remain because Docker removed the stop containers and unused resources during the prune operation. We can also inspect the Docker images currently available on the system. Here we still have multiple application images from previous tutorials, but we can clearly see that the optimized application image is much smaller compared to several older images that are larger than 1 gigabyte. This demonstrates why Docker image optimization is an important best practice in real production environments. We can also visualize the Docker environment directly from Docker Desktop. Here we can inspect running containers, Docker images, storage usage, and optimized application images graphically. Here we can see all the Docker images created and used throughout the Docker tutorial series. Over time, Docker environments accumulate many images, containers, and cached layers that consume disk space unnecessarily. Since this is the final Docker tutorial of the series, let's completely clean the Docker environment. The Docker system prune dash, a command, removes unused containers, networks, dangling images, cached layers, and unused Docker images from the system. As we can see, Docker removed multiple unused resources and reclaimed a significant amount of disk space. Keeping Docker environments clean is another important best practice in real development and DevOps workflows. After the cleanup process, the Docker environment is now much cleaner and easier to manage. Even after running the cleanup commands, Docker did not remove these images and containers because they are still actively running. Before Docker can fully remove the images, we first need to stop and remove the running containers associated with them. This is another important concept when managing Docker environments and performing cleanup operations. Now, Docker can fully remove unused images, cache layers, networks, and other unused resources from the system. At this point, the Docker environment is completely clean again. This is a good practice after finishing labs, tutorials, or large development environments. Finally, let's quickly open Docker Desktop one more time to verify that the Docker environment is now completely clean. Here we can confirm that the old containers, images, and unused resources were successfully removed after the cleanup process. One important detail is that Docker volumes may still exist even after removing containers and images. Docker keeps volumes separately because volumes are designed for persistent data storage. This is actually a very important feature, especially for databases and stateful applications. To finish the cleanup process, I'll remove some Docker volumes directly from Docker Desktop and others from the terminal. This is useful because in real environments, engineers often use both the graphical interface and the command line, depending on the situation. Finally, we'll verify the environment using Docker volume ls to confirm that all Docker resources were removed successfully and the environment is completely clean again. Before finishing, let's summarize some of the Docker best practices we explored throughout this tutorial. We learned how optimized Dockerfiles improve performance and reduce image size, how environment variables help protect sensitive information, and how Docker cleanup commands help maintain a healthy Docker environment. We also explored Docker layer caching, dockerignore files, lightweight images, and production-oriented container workflows commonly used in real DevOps environments. There are many additional Docker best practices such as health checks and production monitoring that become especially important in Kubernetes and larger cloud-native environments. And that's it for the Docker tutorial series. Throughout these tutorials, we explored Docker fundamentals, Dockerfiles, volumes, networking, Docker Compose, PostgreSQL containers, troubleshooting workflows, and Docker best practices. These concepts are the foundation of modern, containerized, and cloud-native environments. In the next series, we'll start learning Kubernetes for beginners and explore how container orchestration works in real production environments. Thanks for watching, and see you in the next series.